Okay, I think I'm recording. Hey guys, welcome to a very exciting video. Today we're going to take a look at this LeetCode problem. It's called max dot product of two subsequences. I believe this was a daily LeetCode question some time back. I thought it was a pretty interesting question back then, and I think it's a pretty interesting question right now. So I thought I would just do my best and try and record it. Okay, something silly is going on. It's not capturing the entire screen. Why? Technical difficulties, huh? Okay. Oh, there we go. That fixed it, maybe. Interesting. Anyway, so you know what? Actually, bring it back. Let's look at the question. So the question goes something like this: given two arrays nums1 and nums2, you are to return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. I really like this question, and for two reasons. The first reason is because it's quite short. It just wraps itself up nicely in just two sentences. And the second question is, as long as you are familiar with each of these terms, such as maximum dot product and subsequences, you essentially have all the knowledge you will need in order to solve this problem. It says hard, but I don't even think it's a hard question. Look at that. Acceptance rate of 62.6%. Oh, you can't see it. Let's see. There you go. Acceptance rate of 62.6%. That's not hard. Anyway, let me try and explain this question to the best of my ability. So we have, let me just bring this to another monitor. And now I'm just gonna copy the first test case. So we have nums1, which is equals to 2, 1, minus 2, 5. And the other nums array, which is 3, 0, minus 6. Okay, so let's try to understand this question. So we are asked to find the maximum dot product of non-empty subsequences of nums1 and nums2. So, and it also says with the same length. So the bit about them being the same length is kind of redundant in my opinion, because you can't perform dot product on arrays of different lengths anyway. So I think it's just there as a sort of hint, because otherwise it wouldn't make sense. And the second thing is, let's try to understand what the max dot product operation even looks like. So if you have an array, let's say a1, a2, a3, and you have another array b1, b2, b3, and these are all one-dimensional arrays, the maximum dot product is a bit more interesting if it were two-dimensional arrays or two-dimensional matrices, but this is just 1D, so it's pretty simple. All you have to do is do a1 times b1 plus a2 times b2 plus a3 times b3, and this is the max dot product. And we are trying to find two subsequences of lengths which are going to be either the minimum of nums1 and nums2 or even smaller, right? We're trying to find two subsequences of the same length which hold to that constraint that I just said from these two nums array. Okay, and think back to an interesting property of subsequences where the array elements you choose from the array have to appear in the same order. That fact and this property is enough for us to devise a solution to this problem. So let's try to understand why. If you want to maximize a dot product, which looks something like this, what is the biggest factor that's going to help you do that? The products, right? So you have to pick two integers or two numbers such that their product is a maximum, because you're gonna get a much larger max dot product from maximizing the actual products than the sums, right? The sums are not going to get you far, the products are. So what we can do is we can essentially try and look at the elements in nums1 and elements in nums2 and try to find two elements from nums1 and nums2 whose product is the maximum, and that could very well be our starting point, right? So for example, consider this. Consider the product of 3 and 5. 3 times 5 is 15. And I think this is a maximum product you can actually obtain from any two integers, or how about this, any subarray of size, using only subarrays of size 1. This is the maximum you can get. Okay. There are other really big products in here too. For example, if you do -2 and -6, you get 12, which is also a big product. Now, essentially, once you find said two integers that give you the highest yield or the highest product, a2 times b2, what you can do is, using the elements that occur before a2 and b2 in their respective arrays, you can try and find other max dot products of those subsequences, right? And that could very well be a1 and b1, right? So you pick two integers and you essentially get the product of those two integers, which is something maximum, okay? And then you look back at the integers that occur before a2 and b2 in their respective arrays. So in this situation, it's just a1 and b1, and you try to find the product of those two integers. And then all the integers following a2 and b2, that's just a subproblem of this bigger problem. That's like the optimal substructure property of this entire problem. So in order to make you understand that a little bit better, consider this. The very solution to this question goes something like this. So the answer for this problem is 18, and I can show that to you. If you go back to here, you can see that the output is 18, right? How do you arrive at 18? So let's say you pick these two products. This is actually the solution. Okay, so if you do -2 times -6, you get 12. Now you look at elements before -2 and before -6 in their respective arrays, so 2, 1, and 3, 0. What's the maximum product you can get out of here? 3 times 2, right? So 3 times 2 end up being your a1 and b1, and that is 6. Now you look at elements after a3 and b3. So, after a2 and b2. So after b2, there's literally nothing. It's just empty. This is the end of the array. So here you have nothing, and this is the end. And your answer is actually 18. Essentially what you need to do is basically this, but there's no greedy way of taking any shortcuts that are going to get us this answer. So you'll basically just have to try every possible solution, and that's how you end up with the answer. So enough talk. I hope you get the gist of it, but once you start coding, you'll actually get exactly what I'm talking about. Alright, so let's start coding. So the way I'm going to solve this is, or rather let me try to walk through how we will build our DP array. So let's bring back our nums. Nums1 is going to be 2, 1, -2, 5. And nums2 is going to be 3, 0, -6. Okay? Let's just try to write them down like this so it's easier to see what we're working with. Now I'm going to put 3, 0, -6 here. Look at that. So good. Now, consider just a subsequence consisting of 3 and 2. So let's say nums1 is 2 and nums2 is 3. So what's the maximum product you can get? 3 times 2, 6. That's it. Now if you do 3 times 1, you get 3. But 3 is actually smaller than 6. So 3 is a better match for 2 than it is for 1. So what you can do is you can just peek at the back and pick 6. Great. So we basically end up doing max of I minus 1 j, which is 6, and I nums 1 of I times nums 2 of j, which is 3. So 6 is better, so we're going to pick 6. Now, if you do 3 times minus 2, you get minus 6, which sucks. It's smaller than 6. So you just peek at the back and then you get the maximum value. 3 times 15, that's the highest you can get, and that's actually the solution. If your question was 2, 1, minus 2, 5, and nums 2 was just 3, 3 times 15 is the answer to your question. Okay, now let's try to look at 3, 0. Okay, now 3, 0 in this case, if you remember from our previous dot product example, a2, b2 plus a3, b3. In this situation, 0 might actually, so 0 is going to be, we're essentially solving for this term. Okay, so 0 times 2 is 0, and that sucks. Better match for 2 is 3 rather than 0. So you look up and you catch 6. So given a subsequence of 0, 3, and 2, the best answer is 6, and that comes from 3 times 2. Again, we do 0 times 1. 0 times 1 sucks, right? 0 times 1 is 0, so that's not a very good answer. But remember this, if a2 and b2 are 0 times 1, okay, and if we look at a1 times b1, so a1 times b1 is using integers that occur before a2 and integers occur before b2. That's going to be 3 and 2. So 3 times 2 is 6. So this is essentially going to be 6 plus 0 times 1. So that is one other edge case we can use. We can either look up, we can either look back, or we can look diagonally and get the best occurred thus far without including these two elements. And if we do this as well, we'll end up with the same answer, 6. So again, if you have 0, 3, and 2, 1 as two subsequences, the best answer you can get is 6. Moving forward, 0 times minus 2, again it sucks, and the best answer is 6. So let's just add 6, and it's gonna be 6 again. Following the same logic, you can kind of work through this yourself, but I'm just gonna speed it up in the interest of time. Next, let's try to look here. Minus 6 times 2. 2 has a better match 3 rather than 6. This is 0, by the way, I'm not sure, just to not cause confusion. So this answer is going to be 6 too, because here you can only pick subsequences of length 1, because that's the maximum you can get out of nums 1, since it's only 2. So 2 times 2 is a better match for 3 than it would be for 6, so that's where you end it. Next, 1 times minus 6 is just minus 6, and 1 is a better match for 0 in this case, because 0 times 1 is 0, and that's better than minus 6. And so it's essentially just this case where you just leave minus 6, you don't care about that, so again you get 6, right? But here's something interesting. If you do 6 times minus 2, minus 6 times minus 2, you end up with 12. And if you pick the solution to the subproblem that occurs before these two elements, before minus 2 and minus 6, that is only using 3, 0, and 2, 1, you get the answer the better answer is 6. So it's essentially 3 times 2 plus minus 6 times minus 2. So that's 6 plus 12 equals to 18, and that's the maximum possible answer. And that rules. Again, if you try minus 6 and 5, that's minus 30. Doesn't work. You can't pair it with 6 and minus 30, that's minus 24, still sucks. So you just disregard this, and the best answer you can get is 18. Now the final thing what you can do is just go through the last column and just find the maximum, and the maximum is 18, and this is your answer. So it's just that simple. Let me try and code this real quick. Okay, so since we're using DP, I'm just gonna say, I'm gonna put nums1 as the columns. So we're gonna say 0 in range length of nums1, and this for range length of nums2. Okay, for I in range, so we're iterating through the outer array, so that's gonna be nums2. For j in range length of nums1, Whoops. Okay, and now we're gonna fill the DP array. Okay, and remember there is 3 possibilities. You can move up, you can move to the left, or you can move diagonally. Okay, so, and we can also, if you move diagonally, you can either pick the diagonal, or you can pick the diagonal but also add the current score. Okay, so I'm gonna say S1 equals to nums2 of I times nums1 of I, of nums1 of j. So this is the score from the current I and j. Okay, it's possible that j is a better match for something before I. So we're gonna say S2 equals to nums2 of I minus 1 times nums1 of j. I is a better match something before j. So S3 equals to nums2 of I times nums1 of j minus 1. So this is us looking up the DP. S2 is us looking back, and now we just need to account for the diagonal, right? So diagonal. So S4 equals to nums2 of I minus 1 times nums1 of j minus 1. But we're starting from 0, so we need to only do this if I and j are greater than 1. So I'm gonna say float minus infinity if I equals to 0 or j equals to 0. Only if that's not the case, then we're gonna do this. And then we can say that dp of I comma j. Okay, sorry, my bad. This is supposed to be inside the dp. We're not trying to sum it again. That's just stupid. Okay, just like that. Yes, sir. So nums2. Okay. I'm kind of dropping the ball, guys. I'm so sorry. We are trying to get this from a DP array, not from nums. This is an awful tutorial. But yeah. So we're peeking up in the, peeking to the back, peeking to the left, peeking up, and finally we're peeking at the diagonal. And dp of I comma j is just gonna be the max of either S1 or S1 plus S4 or S2 or S3, and we're gonna return. So we can do max val equals to 0, or just do float minus infinity just to be on the safe side. For row in DP, you just have to do max val equals to max val row minus 1, return max val. Let's run that. Let's see what we get. Oh, there is a bit of an error. It says string. That's bizarre. Let me try and understand what's going wrong. Oh, that's supposed to be minus infinity, not plus infinity. Okay, so we passed 2 test cases, but we got output 0 when it should have been minus 1. So perhaps we initialize this with minus infinity, but I don't think that's supposed to help. But let's see. Yeah, that was it. Okay, interesting. Let's submit. And there you go. That's a bad tutorial. I really dropped the ball while coding this, but yeah, this is supposed to be minus infinity, not 0. I'm sorry. Because if you pick 0, I think it messes with this condition. So because because negative numbers are also a part of this question, so you can't start at 0, you have to start it at a much smaller limit. And yeah, the rest is pretty simple. And I think I messed around here. I was doing nums 2 times, but we're trying to gauge from the DP. We're not trying to recalculate everything, as you may say. So I hope this tutorial was helpful. I'm sorry if it was a bit all over the place. I'm kind of new to doing tutorials, and my brain is like, it's on frets, I just, there's a lot more going on in there, and I'm not able to put my thoughts more eloquently. Anyway, that's it for me. Leave your suggestions in the comments below, and if anything else you would like to see, I'll catch you the next time. Peace.